We are going to start now. This is a roundtable about big data technology. We will have another one tomorrow for big data more related with use cases and business and companies. I think this is better to have a sort of open discussion about general big data technology, because we have a big field of expertise from buses, streaming, databases, and scientists, data engineers, and so on. So I think one of the first questions could be, or we could talk about big data evolution, the technology, how has been evolving, and what do you think is the future of big data for the next 2-3 years? Just to start.
Big question. All right, so I can kick it off. So I think in terms of evolution, like surely like it has now reached every aspect of computer science. Previously it was just like it started with databases, gone to queuing, PubSub, going to processing. Now it's machine learning. Now everything's following suit. So surely, like in the future, I can see more and more like things that you used to see with mature databases, which is great tool set, great integration with every kind of source, every product out there. I can clearly see a lot more of that over the next coming years. Which is tools are, it's going to become much easier to use. Right now, I think it is still in a place where the tools are evolving and it's kind of hard to use. And then, we still have big data islands. I think in the future, everything's, going to be very easy to interoperate. So yeah, that's how I think about it.
So I think everyone agree complexity is one of the main points now, and this will evolve to make it simpler to use, right. No? And other evolution, the machine learnings, the real-time, new type of databases that really scale out. What is your opinion about that evolution?
Well, I think that one of the things we'll see over the next few years, definitely a lot more use of notebooks. We're tracking that now. And a few years back, if you were doing work with big data, you probably had a lot of scripts that you were writing, and your team would have to manage this through, I don't know, GitHub or check-ins or some kind of code repo. But still, just the setup and the sharing is problematic. So notebooks are nice because now a team can really replay things. And even across teams, across companies, we're seeing more collaboration because of this.
Databases or scale out of data and speed and real time? What's your opinion?
I guess the question is, well, sure, having real time would be awesome on that amount of data, sure. I have a query, I get the result immediately. That's what we all, let's say, dream of. I guess we agree to that. But I'm not sure, like, in what time frame we're going to be there. So currently, let's say one of the phrases I heard from one of my colleagues is, every time you blink with an eye, you have a new technology in the Hadoop world. Sometimes even less, right? So I guess it's a big chaotic situation right now, but I want to add something to that, where we came from. We had that last night in dinner. Well, I'm not sure with whom, but with someone. So coming from, let's say, the early ages, what I did in my studies was doing MPI programs, and now writing Spark on top of a huge cluster is a tremendous difference. And now we are going for notebooks in the end, right? So this makes it even easier. So I totally agree to the point that it will become more easy to deal with that data. That's sure, that's seeable. And we need to do that because, like, we want to have kind of the non-computer scientist audience participating there. We need them there because they have domain knowledge that computer scientists just do not have, right? So if we are able to get them access to the data, we will see completely new applications in the end, what they have. That's one thing. The other thing, yes, real time, but I guess at least next 5 years out, you won't have it without any trade-off, right? So If you're specifying some queries, or let's say some information needs you want to have in real time, you might be able to make them really fast. But since it's not completely clear what application in the end we are aiming for, it's really difficult to decide now in which direction we optimize. And that's also kind of connected back to the situation where we have new technologies coming up all the time because we have new opportunities of doing something and see new use cases where the current technology just does not fit. So we add something and then call it whatever thing Hadoop.
Okay, then I think other point you have been mentioning Hadoop, and what is your opinion about Hadoop MapReduce, Impala, Spark, in the part of Spark MapReduce, Spark Streaming, and these technologies, or even Flint or other technologies? What is the current situation, and do you think there will be a winner, or they will share the market, or they will specialize more for a specific processing? What is your opinion, I think? Well, maybe this is a hot topic to talk about.
All right.
A brave one.
You want to go ahead?
Well, I think it's interesting. I've definitely tracked a lot of the Spark streaming use cases, but you know, Samza provides a lot of quality there as far as robustness and scale. Flink has great features that you know, go beyond even what Spark is doing in many cases, deltas and all. So I think that there's so many learnings that have to come into play for streaming. Understanding how to handle back pressure, for instance, is still pretty complicated. It'll be a while before this stabilizes. I think there's a lot of room for multiple projects so that we can exchange ideas to try to converge at some point later. It's going to be a few years out, though, I think.
But you believe that?
Sorry.
It's just a question for you, but you believe that in the end we want to have like one size fits all in Hadoop?
No, not at all. I mean, I'm really not a believer in the one size fits all thing. Just in industry, certainly, I mean, there'll probably be some winners. I do think that we're like a generation beyond what we had previously for streaming, because I don't know, let's say Storm or S4, things like that. The current generation provides much better features, but it's just there's so much academic work really, or research work that needs to be done. And the problem is that it requires scale that academia doesn't necessarily have access to. So there's a lot of room for industrial partnership.
So I'd love to address that.
Yeah.
So, hello? I'm audible. So the academia thing really tickles my fancy. We are not even there yet, right? So if I was an industrial person, and I have a foot in each camp. I'm chief scientist at NEO, so I do some science. I science the shit out of things, as Matt Damon recently said. And I have a foot in the industrial camp. If I was in the industrial camp right now, Spark 1, end of panel, right? Let's all go home and see our loved ones. How do I know this? IBM advertised at San Francisco Central Station, 3,500 engineers on Spark. Can you match that investment? I can't match that investment. I have engineers that are 35 times more proficient than any IBMer, and I still can't match that investment. So if I was an industrial guy, I'm putting my money on Spark because it's going to be supported by all of the enterprise vendors that I run my business on. And typically my business isn't technology, right? My business is real stuff in the real world. But looking on the other side of it, I would be slightly nervous if I was Spark. So I was in Monterey a couple of weeks ago, and Michael Stonebreaker was there, and he's quite a famous chap, right? He has a little bit to say about databases. He's done it more times than any of us have. And the thing with what I found was interesting, not that Michael was quietly celebrating a Turing Award or any of that amazing kind of, wow, you're cool kind of stuff going on, but that Michael had sort of taken aim at the Berkeley data stack, badass, as they hilariously call it. And on the other side of the country, this is the United States, they're preparing something called Big Dog, where Big Dog is going to kill badass. It all gets really cryptic after some point. What does this mean for us as engineers, as data scientists, as developers, as business users? It means that although IBM has declared effectively that Spark has won, there is now massive innovation and research going on in the premier research universities, particularly in North America, that's going to make Spark look like child's play 3 years from now. And it wouldn't surprise me if stuff came out of the Ivy League and out of Stanford, which is going to rapidly gain traction, where Spark is currently gaining traction. because those universities are just geared to massive potential technology transfer. So I would say, right now, if your job depends on it, bet on Spark. But keep an eye on what those guys are doing, because one of these days, soon, it's going to pull the rug from under us.
There's a good anecdote. I'll attribute this to Christopher Nguyen out of Adato. But there's this generational aspect of where you get a bump in network technology, and then maybe 5-10 years later, you get a bump in storage technology, and then some years later, you get a bump in processor technology. It's just sort of this endless cycle.
That cycle, does anywhere address the CPU RAM technology, or is that just
yeah,
the land that computer science forgot? Because that seems to be a problem for us.
There's the mobility gap that's really, they talk about. But the thing is that I think it's the network side that's behind right now, and that's where a lot of active research. And I wouldn't be surprised exactly if Stanford or MIT or somebody shows up with very radically different networking technology, and suddenly streaming is all different. It's a new game. Also, I think Google is extremely sophisticated in this area and will probably surprise people more often than not.
The one thing I would like to add to that is, as far as new technology is concerned, it takes a while for a technology to mature, right? At the end of the day, developers need like good tools to kind of use the technology, because some of them are very good at certain things, but using them is hard, right? And if you want wide adoption, then the tool set is critical, because sometimes we keep moving from one cool thing to the next, but you need some time for the tool set to kind of mature. And on that front, another point to note, this is more to do with streaming than with data. So for streaming, we call this stream processing now, but in the old days we used to call it app server, which is asynchronous event processing and such. And the key there is, and in the app server space also, no one won, right? It's about writing code. There are always going to be tens of ways to write code, right? This is less true on the data side. In the data side, I think, it's possible for, one camp to emerge more victorious. I think, but on the code side, there's always going to be so many ways to write code. It's kind of hard to imagine that like a streaming platform wins. I think there will be a bunch of them. I think there will be a bunch of ways to write stream processing. Yeah.
But when a certain platform wins, it wins big, right? So we all think of the World Wide Web as being the only game in town. Right. And it wasn't. And when that won out, boom, paradigm shift, right? So if that happens in the streaming space, we're going to be in these chairs 10 years from now, and we're going to be looking back and saying, oh, well, yeah, was there even a world before X streaming?
Yeah, I think stream processing by itself is going to become huge, right, compared to where it is now. And, so the evolution growth is great. But in terms of, saying this platform is going to win versus that, I think it's like saying, what's the better style of writing code, right? And which
mine, obviously. As a developer, it's obviously inherently mine.
Exactly.
You're wrong, and space is not tabs.
There you go.
But let me just throw in something. So summing it all up, coming from the notebook concept you mentioned, which I find really interesting, because you can just switch different backends currently and say, okay, I want to go to Spark or
Neo4j, for example.
Neo4j, for example. Yes,
throw it out there.
Yes, I don't know. There's something on your shirt, maybe. Got it. Okay. No, thing is, like, coming from a notebook concept, like, you as a kind of, let's say, data scientist, I'm just guessing, correct me if I'm wrong, I don't care if it now in the end is called this or that engine, this is the engine, I want to have my data processed, right? So we might even have and should have, point of discussion, another layer that kind of abstracts, say streaming, say whatever, into an interface that is kind of independent of whatever implementation is on. And then we are good to go, because then we can just plug in whatever is there. And then the competition would be fair, because currently Spark gets tons of attention. And yeah, it's relatively hard to handle for Databricks, I guess. Just my gut feeling from the short talks I had with them. But anyways, so...
Not to trivialize the problem, but good research has been done there, right? So the e-science community did a bunch of scientific workflow, scientific notebook work, when we were mere babies, like, a decade ago. So I think there is a good bunch of stuff in the literature about that, but I haven't seen it capitalized on in the way that, for example, Paco picks out as like commoditizing it, just making it accessible to everyday data scientist, if there is such a thing.
Yeah, I mean, it's interesting that there are some companies that have been doing notebooks for a while. Mathematica comes to mind. A very different kind of use case, but very sophisticated what they've got. There are companies that commercialize Jupyter, so Quantopian, Sage Math Cloud, and others. But there's a lot of active research, especially on the collaborative parts of it, like Jupyter Hub. And the project itself, of course, just took funding recently, or I got a grant recently that'll bump up a lot of research there. But yeah, there's a long road ahead, definitely.
Okay, and in this streaming and real-time processing, what will be the roles of the buses like Kafka or other, and the role with the metadata? Because the metadata in Hive, you have some stores to have the metadata, but then it is not traveling to other parts or to the streaming part of the cluster. And so to manage the metadata is something quite complex. Do you think a solution like, I don't know, Kafka plus Zookeeper to have the metadata, move it through the different technologies is better, or the Hive to have it in that context? Or what is the solution for the metadata and the role of the Kafka and other buses in the streaming and real time?
Yeah, I can say a word or two on how we do it at LinkedIn. So at LinkedIn, for Kafka, we do have an ecosystem around it, right? And, like you said, the metadata is a key part of it, like what are the schemas of messages that are going into which topic, list of topics, mapping from, and then schema evolution is a big thing because that happens all the time. And yeah, we have our own homegrown kind of schema registry and a bunch of other things to kind of manage our data. But yeah, there isn't like a single one, like I think in Kafka, you will see probably emergence of like some of these options. We'll probably open source it. I'm sure there's going to be some other kind of out-of-box things coming out in Kafka. But if your question is about, the whole data lineage, because the data starts, maybe gets published into Kafka, goes into Hadoop.
Yes, from ingestion to the
right,
data lake, including governability and security and so on.
That's surely an area where I think there's so much room for improvement. At least I haven't heard of like a complete story. Maybe like some people in Cloudera or Hortonworks are thinking about it. I don't know.
It's a hard problem, especially when you're working with a cluster and you have to take into account that some nodes will be disappearing. So, how do you keep that all in sync? I mean, just schema evolution alone is hard, but then trying to run that across the cluster where there may be different versions of apps running, very difficult. You do checkpointing in Spark for the metadata specifically. I haven't seen enough of that. I know that's been a hot debate in catalog has been a hot debate in big data.
I think most companies, at least so far, seem to be burning out their own versions. So we do our own thing in LinkedIn to make it reasonable for our developers to use. But I'm sure there's room for someone, who's a infrastructure player to come in and kind of solve it, so.
Okay, what about the evolution of databases? I mean, from transactional databases to MPPs to more specialized, because one of the things that we like more about the NoSQL databases are that they are very specialized, so you can use a good one for graphs or for relations and so on, of course.
Of course.
And you can use for schema, dynamics schema, something like MongoDB or other databases. And they are very specialized. So do you think that in the future the companies will use several databases, including MPPs, transactional, NoSQL, and they will combine, and this data fusion trend that also the companies are using will be the future of data layers in the companies, or what about this? Because we have SAP HANA and Sapora here also, so you have a lot to say about this.
Yeah. Well, it's a huge question, actually. But coming from the perspective of the current situation that we still have not that stable, this is the database on Hadoop or this is the database somewhere else, I think at least in that space, people will use specific things, what they need for, similar to discussion we had with Flink, with Spark, with Neo4j, all the things. So it's a very specific thing. So coming from SAP HANA, because you mentioned it, what we tried there is putting all TP and all up in a single system. This works to a certain scale, and then we are done, right? That's one thing. And we don't do scale out then on a Hadoop, but then the question was for us as HANA Moro developers as well, what to do first, right? So what do we want to improve there? And we went for going for all-up queries first. That's why we optimize all the stuff we do for all-up. But that's one direction, right? We are obviously aware of several other ones, like say Hive and all the other databases that's out there that are optimized in a different way. Say, for example, or we have like Cloudera bringing Kudu out. It's not really a database; it's more as a storage layer. I know, but still, like it does different partitioning as we do. So these are really like the fitting to the problem you have, and it's a kind of a vast amount of things you have to look at.
Yeah,
putting
I agree actually. Like you need the right tool set for the right job, right? And data is a space where there are just like at least 10 different patterns, and having one common database which is going to support the 10 patterns, in a great way. At least I don't think is going to happen anytime soon. And you just need the separation of concerns. You need products to be good and great at what they're doing, as opposed to like one size fits all. So.
But again, the question would be, what kind of language do we put on top, right? So what we had with SQL, at least at some point, we were being like able to switch from, at least to some degree, from one system to another. Say some degree, but having at least a common language would help a lot.
Definitely, I think is possible. In many of these areas. Probably, I'm not sure in all areas, but I think because there are limits to SQL as well.
Sure, well, tons of limits.
I mean, there's an old notion in computer science that it's hard to distinguish between a really good file system and a database, and vice versa. And so I think that when we look at some of the better work in distributed file systems, I think that will have more impact on database. I think we see this some with Cassandra use cases because they are absorbing what would traditionally be database.
Yeah, I was talking about this point because Cassandra is gaining some use cases well related to transactional processes. It is very good writing, and so on. So it is competing with the normal, more SQL ACID paradigm. At the end, well, our opinion was that you will have a combination of data stores, very specialized. There is not one that will fit everything, but it was more in the evolution of, for example, Greenplan is something like a distributed Postgres. You have the MPPs, Exadata, SAP HANA. You have Cassandra, which is also transactional up to some point. So in that, for transactional OLTP, what will be the evolution? To go for something like Cassandra, something like MPP, something like, I don't know.
Well, there's another cynical answer also, going back to Michael Stonebreaker, is that he usually starts a new company every 2 years or so with an entirely different database paradigm. So I think we just need to watch Michael Stonebreaker, and that'll tell us what we're doing with database.
So look, I mean, the answer to me is very obvious, and forgive me for being so cynical. Graph's already won. You guys just didn't realize it yet. LinkedIn kind of get this, but they're not being super explicit about this. The SAP guys have a graph. The graphs are going to win. What's more interesting to me is acidity, right, and transactions, right? Do you remember transactions? They're the things that your granddad used on a database, yeah, or your grandmother. And they're so uncool. And Neo4j was weird because we kind of kept them because we're Swedish, and Swedish people build safe things like Volvos, right, like an airbag on wheels, and we're sort of proud of that, weirdly. Transactions are coming back. Transactions are on their way back. Not transactions as we knew them, big, contended, slow, annoying transaction processing transactions. Transactions are coming back, and they're sexy. There are two guys in particular I think you need to keep an eye on this. And it's not Stonebreaker for once, actually. And it's not Pat Helland, although these guys are phenomenal people. There are two young guys, two young bucks, Peter Baylis and Diego Ongaro, who's one of your colleagues, actually. These guys are making transactions sexy again. And we're not talking about slaving through Lamport's Paxos paper and trying to figure out how to make that work, because there are few people in the world that can do that. But we're talking about transactions which are high throughput, non-contending, and highly concurrent, while maintaining ACID properties. Your colleague Diego's work on Raft was one plank, one pillar in the future of ACID transactions. Baylis's work on non-contending transactions with my friend Alan Fekete was about allowing transactions to execute in parallel for massive throughput, but only coordinating them where they're going to overlap. Because it turns out if you don't overlap, if I only write to Paco's record and I only write to Óscar's record, these transactions don't contend. We don't need to coordinate them. And suddenly you start to get throughput that is asymptotic on the best of the non-transactional stores. This stuff's coming back, and it's going to be like Back to the Future for us, and it's going to be awesome.
So, guys, I'm sorry, we have to, 30 seconds. It's pretty interesting. We should have double the time, but we have more sessions.
Oops.
Well, anyway, we should also talk about big data and cloud and things like this. So, for next edition, maybe. So, if there is any question or
there's one there, maybe. No. Okay. So anyway, I have to thank you, the five of you. It's been very interesting, better than ever. So thank you very much.
Thank you.
Thank you.